We are now going to look at proofs when it comes to SURDS. So for example 1, it says show without a calculator that square root of 32 minus square root of 50 plus square root of 18 is 4 over square root of 2. So basically what we're going to do is we start on the one side, and normally with proofs you can start on either side and work your way to the other side. So you want to try and see which side is the easiest or has the most that you can simplify. So we know we can go ahead and start with that. We can say square root of 32 minus square root of 50, and normally in proofs we first write out the initial the expression, how it looks initially, because we want to take it from there and prove that it's equal to the other side. Okay, so this is 2 times 6, because normally when we work with SURDS we want to prime factorize. So this is 2 times 16, and they say don't use a calculator, so we're actually not going to use the calculators to prime factorize. This is 2 times 16. 16 is a perfect square. 2 times 25 and 2 times 9. So all of those are perfect squares. So let's just write that out. Okay, and then the perfect square is going to come out. This is then 4 square root of 2 minus 5 square root of 2 plus 3 square root of 2. Okay, these are then like terms, which we can add and subtract. 4 minus 5 is minus 1 plus 3 is 2, so 2 square root of 2. Alright, now this is then simplified, but it still doesn't look like this side. Now on this side, we see that we can rationalize the denominator as well. That's something we can do there. So in this case, we're not just going to start from the left-hand side and work our way to the right-hand side. Here we're actually going to say, okay, this is the left-hand side, okay, and that's equal to that. Now we're going to take the right-hand side and see if we can also equate it to that. So we have, this is 4 over square root of 2, which we are then going to rationalize, multiply both top and bottom with square root of 2. Then we have 4 square root of 2 over 2, which simplifies, if we cancel there, to 2 square root of 2. Okay, so we can now see that the left-hand side, say therefore, the left-hand side is equal to the right-hand side, and that completes our proof. Okay, example 2. Show that this is equal to square root of 3 plus square root of 2. So we're just simply going to start here. I've got 27 plus square root of 18 over 5 minus square root of 2 multiplied by 1 over 5 plus square root of 2. And here we can start off by also prime factorizing. This is 3 times 9, and that is 2 times, this is 2 times 9. Okay, so I can write that 3 times 9 plus 2 times 9 over. Now also in the same step, we can simplify these fractions by multiplying the numerators and multiplying the denominators together. So this is all over square root of 5 minus square root of 2 multiplied by square root of 5 plus square root of 2. Alright, these 9's come out. They are 3 square root of 3 plus 3 square root of 2 all over. Now this looks like difference of squares, and we know that when we factorize difference of squares we get x plus y and we get x minus y. Now this resembles the form, that the factored form, so we can just take that back to the compound form. So this is going to be, take this the square the first one, which is just 5, minus square the second one, 2. Okay, and then factorizing out these two terms have a common factor. We can factor out the 3, which leaves us with square root of 3 plus square root of 2, and this simplifies to 3, which means these two can cancel, and then you're just left with square root of 3 plus square root of 2, and that is basically what we wanted to prove. Okay, now for example 3, if x is this and y is that, remember determine x, y in terms of a. Okay, not too hard. Xy will then be equal to, if we just substitute the values in terms of a, 3 minus square root of a over 2, and 3 plus square root of a over 2. Right, multiplying two fractions again. So this is 3 minus square root of a multiplied by 3 plus square root of a all over 4. And difference of squares again. So that's 9 minus a over 4. Okay, that was quite simple. Then for example 4, if a plus b is positive and a plus b squared is 3, show that 18 over square root of 3 is 6a plus 6b. Now this one is slightly more complicated. Now if we look at what we need to start with, or what we are given to start with, and where we want to end up, what do we need to do to get to where we want to end up? We want a plus b like on its own, but here we have a plus b squared. So how do I get rid of this? I just take the square root. So if I write down a plus b squared equals to 3, we take the square root. Okay, let's take the square root on both sides. And this is why it's important to note that a plus b is positive, because remember, when you take the square root of a number, you can either say it's plus or minus. So this is positive. Then we're left with a plus b will be equal to square root of 3. Okay, so what else do we need? We need 6. So we can multiply through everything with 6. We can say 6a plus 6b is equal to 6 square root of 3. Alright, now this side, it's still not equal to that. And the next thing we can do is we can see that the square root of 3 is in the denominator. So what I can do is I can treat this, okay, make it a fraction, and then I can multiply top and bottom with 3. Okay, and I don't have to do that on the other side, because basically what I'm doing is, let's say I've got 2 over 4 as a fraction, and I can put it in its equivalent form, like let's say we multiply top and bottom with 8. Then you get 16 over 32, and these are just equivalent forms. So in the same way, I'm just going to multiply this fraction with the same thing at the top and the bottom. Okay, so therefore we'll have 6a plus 6b will be equal to, this is 6 times by 3 over square root of 3. Okay, so therefore we can say 6 times 3 is 18, so 18 over square root of 3 is equal to 6a plus 6b.